Hello everyone, welcome to the channel IGCSE and GCSE Maths School. Today too we are going to do an interesting question of mathematics. Now this is the question. You have A equals BC over D times M minus N, where B equals 80, C equals 40, D equals 30, M equals 60, N equals 40. All correct to nearest unit. Find upper bound and lower bound of A. Second part, range of value of A. We will see. Now say all the values have been given correct to nearest. Sorry, it should be nearest. Nearest 10. All values have been given correct to nearest 10. Sorry. Right, okay. Now look at. Now the question A. A equals B, C over D minus A. Okay. Now this is the thing. Right. Now see. Now this also can be viewed as a division of two terms. One term is this whole thing, other term is this whole thing. BC divided by D into M minus N. Then you have to divide this whole thing by this whole thing. Therefore, this is division. Therefore, A is quotient, or A is the answer of division. Answer of division is always called quotient. Then D is the quotient. The answer of this division is quotient. Therefore, quotient. Then here, what applies is the rules of finding upper bound and lower bound of quotient. What is the how to find the upper bound of quotient? Upper bound of quotient equals upper bound of the dividend, that is the part above the line, upper bound of the dividend divided by lower bound of the divisor. Then this is called dividend. This is called dividend. Dividend, this part. This is called divisor. Divisor, right? This is called divisor. Then dividend and divisor. Dividend is the top part. Divisor is the bottom part. Right? Okay. Then what is how do we find the upper bound of the quotient? Upper bound of quotient equals upper bound of the dividend divided by lower bound of the divisor. Then we will write it first. Then write upper bound of A equals upper bound of BC. And how to find upper bound, and other one is a lower bound of what? D minus N. Okay, that is the, you find the lower bound of upper bound of B minus top value and lower bound of bottom value and divide. That is how you find the upper bound of A. Then lower bound of A. How do you find the lower bound of A? Lower bound of A. How do you find the lower bound of A? Lower bound of A, lower bound of a quotient. Lower bound of a quotient equals lower bound of the dividend divided by the upper bound of the divisor. Lower bound of the dividend divided by the upper bound of the divisor. That means lower bound of the top value. This one, L, lower bound of the top value, that is BC. Then divided by upper bound of what? Upper bound of what? D bottom part, like that, bottom value. Right. Okay. Right. Okay. All right. Now we will find. We need now the upper bound of BC. Then upper bound of BC. Right. What is the upper bound of BC? Upper bound of BC. BC means what? B multiplied by C. That means upper bound of BC. Then upper bound of BC. We need upper bound of BC, lower bound of BC, lower bound of D M minus N, and upper bound of D. Right, we need 4 things. No, right. We will calculate BC here. Then write upper bound of BC. This is what upper bound of BC means. Upper bound of product. BC means B into C. Then B is a product. B into C is a product. Then we have to use the rules to find the upper bound of a product. What is the rule for finding the upper? What is the method to find the upper bound of product? Upper bound of product equals product of upper bound. Then upper bound of BC equals product of upper bound of B and upper bound of C. Therefore, you write here upper bound of what? B into upper bound of what? C. The upper bound of B. How do you find upper bound of B? Upper bound of B is the corrected value. That's the upper bound of a single corrected value. The general formula is corrected value plus degree of accuracy over 2. Go to the upper bound. The corrected value is 80 plus degrees. There's a degree of accuracy 10. Then 10 over 2. Right. Then multiplied by upper bound of C. Upper bound of C. Upper bound of C. C is 40. 40. Then 40. That's upper bound of a single corrected value. The corrected value plus degree of accuracy over 2 plus degree of accuracy is how much? 10 over 2. Right. Then that will be how much? That will be, here it is 1085. That is this will be here 85. Then into this one will be 45. Right. That will be the upper bound of that. Right. Okay. Then you go to the lower bound of BC. Then lower bound of BC. Lower bound of BC. How do you find the lower bound of BC? That is also the lower bound of product. Lower bound of product equals product of the lower bounds. Lower bound of product equals product of the lower bound. Then therefore lower bound of BC, product BC equals lower bound of B into lower bound of C. Then you can write this lower bound of B into lower bound of C. Lower bound of C. Right. Then lower bound of B. What is the lower bound of B? Lower bound of B, then B. How do you find the lower bound of that? Lower bound of single corrected value, that degree of accuracy, that is the corrected value minus degree of accuracy of 2. What is the corrected value of B? That is 80. Then minus degree of accuracy 10, 10 divided by 2. Right. That one. Then next one. Lower bound of C. Lower bound of C, again, lower bound of single corrected value. Then general formula is corrected value minus degree of accuracy over 2. That is how to find the lower bound of a single corrected value. Then the then corrected value of C is 40. Then minus degree of accuracy is 10 over 2. Right. Then you take this. This one will be 75. This one will be 45, 35. Like that. Okay. Okay. Then you got what? Lower bound of this. Then this case, D M minus N. Right, this case. Then D. Then you have to find the lower bound of this. Lower bound of D M minus N. Here also there is a product here. Then we'll find upper bound first. Okay. Upper bound. Upper bound of D M. Here there is a product here. D multiplied by M minus N. So therefore, we have to find the lower bound of upper bound of product equals product of upper bound. Then upper bound of then D into what? Upper bound of what? Upper bound of what? M minus N. Okay, that is how you do. Right, then you find the upper bound of D. How do you find the upper bound of D? Upper bound of D corrected value plus degree of accuracy over 2, that is the D value 30. Corrected value is 30, then plus degree of accuracy is 10, nearest 10. All numbers are written correct to nearest 10, therefore 10 over 2. That is that part. Then upper bound of M minus N, that is, this is the upper bound of difference. You know upper bound of difference, we found it. Upper bound of difference is upper bound of the larger corrected value minus lower bound of the smaller corrected value. Then therefore this one here, it will be upper bound of M. You find the upper bound of M. Upper bound of M will be corrected value of M, that is 60 plus degree of accuracy over 2. Then from that you deduct the lower bound of N. Lower bound of N, the corrected value minus degree of accuracy over 2, lower by the 40. Then minus, then 40 minus and corrected value of 2, this one. Okay. Now we will calculate. Then you get here it is 35, then minus this whole thing, 60, this 65, this is 65, then 40, then 35. Okay, 65, 35, 30. Then 35 into 30 will be the what? 35 into 30 will be the upper bound of m minus n. Then lower bound of m minus n, next one. Now I will write here lower bound of dm minus n. Then write here lower bound of d m minus n. Yes, m minus n. Yes, how much? Then that is equal to what? This also product. Lower bound of product equals product of the lower bounds, then lower bound of d, then into lower bound of this one, m minus n. Lower bound of d, that is corrected value minus degree of accuracy over 2, d is 30. Corrected value is degree of accuracy is 10 over 2. Then that term multiplied by lower bound of m minus n. Lower bound of a difference. It is calculated by lower bound of the larger value minus upper bound of the smaller value. Then lower bound of m is 60 minus 10 over 2. Right? Then from this one you have to deduct. Then from this one you have to deduct again the upper bound of n. N is how much? 60. Then 60 minus 60 plus upper bound of n. Upper bound of n how much? Upper bound of n is n value is 40. Sorry, n value is 40. Corrected value of n is 40. Upper bound is plus degree of accuracy over 10. Degree of accuracy is 10. Right? Okay, 10 over 2. Then you calculate. Here 35. This one will be how much? 60. This is 55. This will be how much? 45. Then 55, 45, how much? 10. Then 35 into 10. Now we have found all necessary particulars for finding this. Now we will substitute in this one. Then upper bound of A. Upper bound of A is what here? This one. Upper bound of BC. Upper bound of BC here. 85 into 45. 85 into 45. And divided by what is the lower bound of D? M minus this one. 35 into 10. Right. D 30. I have made a mistake here. I'm sorry. Yes. You have to find the lower bound of D. Yes. Lower bound of D here. Then it will be D how much? D is 30 minus degree of accuracy over 2. This one. Then into lower bound of m minus n. Lower bound of difference, that means lower bound of the large value minus upper bound of the smaller value. Then lower bound of m 60 minus 10 over 2. Then upper bound of n, that is 40 plus 10 over 2. Corrected value plus degree of accuracy over 2. Right, now this one. Now here it is 25. Then this will be here 65, 65. Then minus this one will be how much? This is 45. Then 65, 45. Sorry, this is 55. I'm sorry, this is 55. 55, 45, 10. Then here 25 25 into 10, right? Okay. Then lower bound of D, 25 into 10. Okay, then you can find here 5 times 5, 5 times 9, 5 times 17, then 9 times 9 times 7, 63, 3, 6 is left, 9 times 1 is 153, and divided by 10 is 15.3. That will be the upper bound of A. Then go to the lower bound of A. We need lower bound of BC. What is the lower bound of BC here? 75 into 35, right? 75 into 35. What is the upper bound of D? We need the upper bound of dm minus n. Upper bound of dm minus, upper bound of dm minus n here, 35 over 35 over into 30, right? Then 35 goes, this one 10 times, then 3 times 10, 3 times 25, then 25 divided by 2.5, right? Okay, then that is the answer for the first part. The second part, the range is always lower bound less than or equals the actual values of the particular quantity, and less than upper bound. They have to follow that format and write. Just to write the statement following the format to give the range of values, right? Always lower bound 2.5. There's nothing to do after finding these two. It's just to write in the format. That's all. 2.5, then actual value of what? A less than upper bound 15.3. Okay, that's all. That is then the full question has been fully answered. Now practice this question several times and try to gain the necessary mastery of the particular area of mathematics. And with this, we finished our series of videos on rounding of numbers and upper bounds and lower bound. Go to the playlist rounding of numbers and upper bounds and lower bounds, and you can watch series of videos on this and can gain a comprehensive knowledge of the subject of upper bound, correct rounding of numbers and upper bound and lower bound of numbers. Okay, with that, today's video is close. Today's video is close, and expect to do a new video next day, and expecting to meet you in that video. I stop. Thank you very much.